In number 25 here, they've given us a function with some weird letters. H of w is equal to, and here we go, the square root of w multiplied by e to the w power, and they're asking us to find h double prime of 1. Okay, hopefully you guys knew how to get started on this one. Before we can find h double prime of 1, we need to find the general second derivative, h double prime of x. And you can't find h double prime, I should say of w, not of x. You can't find h double prime of w until you found your first derivative, which would just be h prime of w. This looks like it's going to be loads of fun. All right, here we go, guys. We need to take the derivative of this function here, which clearly is expressed as the product of two different monomials, really, both in terms of w. So that's going to need the product rule. First factor is going to be the square root of w multiplied by the derivative of the second, and the derivative of e to the x is just e to the x, so the derivative of e to the w would just be e to the w. First times derivative of the second, plus the second factor, e to the w, multiplied by the derivative of the first. And what we really should be doing here, guys, is thinking of this as w to the 1/2 power, and then just doing the power rule on that. So that's going to get us a 1/2 times w to the negative 1/2 power. Now, what I've written right there, everybody, is mathematically correct, and I'm wondering if it would be worth it to take the time to rewrite this so that this term now became, now I think I'm probably not going to do this, so probably don't write this down. It would be e to the w in the numerator. All over, we would have a 2 and then a square root of w down there on the bottom. Now, I could rewrite it that way, but on my next step, when I go to take the derivative of h prime, I would need to differentiate this term right here, which would require the quotient rule. The way I had it written before, it would require the product rule. Really, they both should work, but I think most of us would agree that the product rule is probably easier to deal with than the quotient rule. So even though that thought occurred to me to rewrite that, and I think it was prettier the way that I had it drawn, we're probably better off leaving it as is right now. So there's h prime of w, and now let's go to find our second derivative, h double prime of w. And this is going to get even more fun. All right, everybody, unless I just had an idea before I move any further of what might make our life a little bit easier. That first derivative, if you'll notice, is made up of two terms, everybody. They both have an e to the w. I'm going to factor that e to the w out in front and leave us then with a square root of w, which I tell you what, I'm going to rewrite that as w to the 1/2 power, plus this ugly term of 1/2 w to the negative 1/2. Now, the reason I did that, guys, is because looking ahead at what I'm going to have to do for h double prime of w, I was about to have to use the product rule once right here and then again right here. So using the product rule twice, doable, but not a whole lot of fun. But the way I've rewritten it right here, now I only have to use the product rule once, and I think this is going to be a little bit easier. So here we go, h double prime of w. The first factor is just this e to the w out in front, and then times the derivative of the second. All right, I'm going to throw that in parentheses. The derivative of w to the 1/2, 1/2, w to the negative 1/2 power. That's that one. And then plus the derivative of this term. So the negative 1/2 exponent gets multiplied by the positive 1/2 coefficient to get us a minus 1/4. The base is still w, and we drop the exponent by 1 to make that negative 3/2. All of that, you guys, is first factor times the derivative of the second. Plus, we now need the second factor, and I think I can cram this in here, guys, w to the 1/2 plus a 1/2 w to the negative 1/2. That's the second factor, times the derivative of the first, which is just e to the w. All right. So at that point right there, you guys, I think my answer is mathematically correct. However, I'm trying to think of what we probably ought to do next right here to write this in a different way. And I'm just kind of curious. I'm going to sneak a peek real quick, guys, at the solutions manual. And in 25, oh, I'm on the wrong section. In 3.5, number 25, that's what I was getting at here. Let's take a look at how they've got that. I'm actually thinking we should factor out the e to the w again and get an answer that's in factored form. What did they do for theirs? Oh, Actually, I take that back. It doesn't really matter because we're not just trying to express the general derivative, we're supposed to evaluate that at 1. So I am much less concerned about writing this derivative in a nice manner. I'm going to go ahead and just cram the 1 in there and see what happens. So h double prime of 1. When you're evaluating a derivative and you get a constant value, this will probably work itself out pretty nicely. So everywhere there was a w, we now replace that with a 1. So e to the first power is just going to be an e. Now, they were nice to us here, guys. If w is 1, 1 raised to any power is still just going to be 1. Times 1/2, we're going to get a 1/2 right there, minus a 1/4 times 1 to a power, that's just 1, so that takes care of that. Plus, e to the first power is again just e, and then in parentheses, 1 to the 1/2 is 1, plus 1/2 times 1 to the negative 1/2, that's a 1 as well. So that's where we came up with those e values right over there. And let's see what we've got here, guys. 1/2 minus a quarter is 1/4, so that first term is 1/4 e, and then plus 1 plus a half is going to be 3/2 e. So if I think about that real quick, that 3/2 could be rewritten as a 6/4. 1/4 plus 6/4 is going to be a 7/4 e, and that is the correct answer here we were looking for problem number 25.